Yes. Just for my inner monk, I have to leave the whole room. Yeah. Hello, everyone. I know it's been quite a journey to come up here, so thank you for joining me today. My name is Annika Burmeister. I come from Salzgitter Digital Solutions, and you will maybe find out what that means today. Well, yeah, come in, take a seat. Together, we will see an example of how mathematical optimization plays a pivotal role in addressing real-world challenges and how it improves decision-making processes in the production at the Salzgitter group. I've got a short question to the great audience. Does anybody know Salzgitter? Salzgitter group? Didn't think so. Didn't think so. Salzgitter actually is a city located in Lower Saxony in Germany, and the Salzgitter Group is a German steel manufacturer. And I will give an introduction so that you know a bit more about the company. The company itself is quite young, but it has a great tradition in Germany and in the steel manufacturing process. For more than 150 years, the companies of the group have been synonymous with sustainable and innovative manufacture of steel and technology products. And what has started with the idea of making steel and iron from ore located in Germany, Lower Saxony, has evolved into an international group that includes renowned brands such as Peinaträger, Mannesmann, or KHS. Today, around 25,000 people work at the Salzgitter Group to provide customers from a range of sectors with high-quality steel products. Well, it's a globally present group, as you can see. We had a crude steel production last year of 6.1 million tons, and also a trading volume of 3.6 million tons. And what's not so well known is that we're among the top three producers of beverage filling and packaging machinery worldwide. Salzgitter has a diversified product portfolio. I just give you some examples on the slide. Our core competencies are in the production of rolled steel and tube products, as well as specialist machinery and plant engineering. Just some numbers for those who are interested. I won't go into detail on this slide. But you can see there are different business units, and the main drivers for the group are the steel production and the trading sector. Right here you can see how the different business units are subdivided into the single companies. I just want you to pay some attention to the right, industrial participations and consolidation, because right there you find Salzgitter Digital Solutions. That's the company that I actually work for. What do we do? The Salzgitter Digital Solutions Group mainly wants to integrate business processes into uniform IT solutions that focus on the whole and the entire workflow to provide our customers within the group, but maybe external customers as well. We have some proven practical know-how because we've worked together with the Salzgitter Group and the production process for many years. I myself have been at the company for a bit more than 6 years now as an expert on mathematical optimization. And I would like to tell you about the More Rules decision box that we use. That's the product that my team offers to the customers within the group, and that's a decision-making tool that we set up. This tool is mainly divided into two components. One of them is a business rules tool that is offered by IBM Operational Decision Management, and the other is mathematical optimization powered by Gurobi. Wherever this last letter got a new role. It did not on my computer. The business rules, is this raining? Yes, it is. The business rules are meant to be a single point of truth for business logic. It's meant to separate the application from the business logic so that the users don't have to incorporate the logic into the code itself, but it's separated and the know-how gets out of the people and the single computer or code that is somewhere within the company. It's a centralized tool that has been established within the group for more than 10 years. It's supposed to tackle problems that can be formulated as if-then conditions, for example, or in a table-like structure, so not too complex questions. And one big advantage is that the customers can make changes on their own. There's a web UI that they can use, and where they can see the structure and the rules. They have maybe implemented themselves or got some help doing it, but they can maintain the rules themselves and adapt to new situations. And on the other hand, we have more complex problems, as we all know. Maybe we have multi-criterial objectives, or we have to identify a good or maybe optimal solution out of many options, and that's where mathematical optimization comes into play. And these tools cannot be just used separately, but they can be combined together and to have synergies. For example, I don't know if all of you have a mathematical background, but maybe you've heard of traveling salesman problems, where you try to find a route connecting cities and to minimize distances. And you could think of the rules, business rules, giving you the distances between the cities, depending on your special input data and program. That's what we do, for example. We have a production process, but the rules tell us something about the input data and about the cost that we consider this. And this is fed into an optimization problem. So the two tools can work together very good. This is some technical point of view. We host 3 servers. One of them hosts the database and the application itself that we offer. A second one executes these business rules I just talked about, and the third one is an execution server for Gurobi optimization. We have a compute server license with Gurobi, and we have all 3 of those, of course, for production stage as well as testing stages, so different stages. And on the other hand, we have our customers who have some kind of client system, ERP, for example, but whatever it is, it can be connected to our application and communicate with it directly or via some kind of middleware, whatever is necessary. And as I mentioned earlier, the customers can maintain the business rules as well via web UI. Well, this is most of the structure that we offer, and this is incorporated into a new tool that I want to talk to you about. We use it for integrated production planning. That's a term I came up with. Let's have a look at the typical planning problems we are facing during the production process in a steel manufacturing context. Most of them can be put into one of 2 categories I would call sequencing or knapsack, or maybe multiple knapsacking. There are many plants that have a storage in front where there are many pieces, like hundreds. Sometimes it's hundreds of pieces in a storage, and you have to schedule them somehow and decide in which order they should be processed in your plant. So naturally, the question arises, in which order these should be processed optimally, whatever optimally may mean in that context. And how can you make sure that the machine can handle the sequence you give it? That's a constraint where maybe these rules I just talked about come into play. They can give you information about what's a feasible solution. And on the other hand, as you might see from the second picture, we have very big so-called annealing bells. It looks quite small in here because there's no human being next to it, but it's several meters high. I think it's at least 5 or 6 meters high, and it can hold up to maybe 150 tons. So you have to put the rolled steel into it to heat it up again, to stack these one on the other. And as you can imagine, it costs a lot of energy to heat this up. Sometimes the heating times are about 3 to 4 days for one bell. So as you can imagine, if it's possible to save just one of the bells per week, for example, saves a lot of energy and money. So you ask yourself how to combine the pieces to save time, energy, to minimize the number of necessary machines. And of course, how to make sure that you can handle the combinations that you just put. You don't want a piece that takes just 2 days together with a piece that takes 4 days, because it would be a waste of time and energy. So these are typical planning problems that humans are facing and solving, but maybe that could be done better. And within the company and the group, we came up with the idea and the vision of a new tool that we wanted to implement. A tool that is for the planning team and supports it and enhances it with its decisions. We have all the integrated data systems in the company, like ERP or material execution service for material tracking. So you know at every stage of the process where a piece is, what has to be done next with it, how much is its weight, how thick is it, whatever you want to know. The data is there, that's not the problem. And on the other hand, we have the know-how of mathematical optimization and business rules combined in my team, and that is supposed to support the planners as well, to make intelligent decisions during the production process. The tool we came up with, it's not my name, I tell you. It's called POSH, which is short for Planning, Optimization, and Smart Heuristics. Everybody loves these abbreviations, I think. And it offers a tool as a platform-independent web service, which is quite important. So the users don't have to install anything on a local machine. Not everybody has a local machine at all within the production context. And it can be accessed from anywhere within the company's network. It has user and session administration as well as authorization and role administration. Everyone has a user within the company's network, user credentials that they use to log into Windows, for example, or whatever. And these credentials are incorporated in our tool. So maybe not everyone has to have the same rights for every plant. Maybe he works on the one and not on the other. So maybe he shouldn't see all the dialogues. The business rules are integrated, as we just mentioned. We want to get information from them, and we want to use the mathematical optimization for planning purposes. The planning functionality is very important for the users and for their acceptance. They need to see all the important dialogues that they know from an maybe very old tool, let's put it that way, that they use now. They want to display all the information that's necessary for them. And that can be quite a lot, I can tell you. And it has to be integrated into the IT landscape that's already there, like ERP, material execution systems, whatever you have at the company. It also offers a uniform look and feel that the users know from other tools that we've already implemented, and so they feel familiar and know how to use it. And it comes in a scalable Docker environment, so it can easily be rolled out. Has some features like backups, monitoring, support from people like me if it's for the optimization aspect, and archive. So you can look up what's been done before, of course. And last but not least, it comes with encrypted communication as well for security reasons, which are important. All these different stages have to communicate somehow. We have, on the one hand, we have the production side that needs to get the information in their systems. What is the plan? We have the material execution system, the SAP ERP system that holds all the information and data. We have the user interface that should display them and that should give the functionality. And on the last hand, we have the more rules decision box I just talked about that we offer And all these different tools communicate via middleware. It's SAP Process Integration. It's short for PI in our company. They handle all the communication between the different systems and maybe some mapping that has to be done to communicate from one database to another, for example. And I think I've had some theory now, and I would like to show you some screenshots of the tool so that you get an idea. This is like the login screen that you can use your credentials on, and then you will be brought to an overview. There's lots of information here that I won't go into because it's not necessary for today's talk and not necessary to see where optimization comes into play. But you can see up here, there's a drop-down menu that opens up where you can choose which plant you want to make a plan for today. Of course, Annika Burmeister has all the rights. She can plan anything and we can choose from. And whatever you choose here, you get to a new overview. And I had to anonymize the data down there because people thought like all of you would produce steel right after you see it. So I could not show you the details in here. But you see there are lots of common columns with information that you can filter, that you can search for, or that you can sort in whatever way the planner may want. Because the first thing they have to do, this is all the storage in front of their plant. They see all the pieces lying there and all the details about it. They can now choose for maybe the next 8 hours which pieces should be processed. For which pieces do I want to sequence? And then they can just drag and drop them up there to the white space into their program. There are different ways to do it, but you can just drag and drop them. And if you do so, they will appear up there. And is this actually the... No, I'll just show it from here. We have a column here where you can see some red numbers. This is where business rules have already been requested in a live mode. They show you how good these two pieces can be combined together. Because maybe at this plant, the pieces have to be welded together before they can be produced. So it's important that the thickness or the width must not differ too much, for example, because otherwise it would be a problem for the plant. And all this you can see down here, up here. You can drag and drop and change the order if you want to. And in live mode, this will change the information you see. Some different rules are executed as well. And all the colors you can see come from some kind of rule that the customer wanted and shows and displays information. You can have a mouse over and see some more detail if you want to, and things like that. And right now, you can, for example, have a dialogue that lets you fix some of the pieces for the optimization. So if you say these pieces should be processed in this order no matter what, then you can just fix them and the optimization won't change this block, we call it. You could also fix the first or the last piece of your program, because as a human you might know more than the machine does. It's a rolling production, it never stops, it's 24/7. So maybe you know something that has been done before, the program that will be produced right before your program, and you will make sure that the first piece can be welded to the piece that comes before. And maybe you want the last piece to be something like good for everything, because you don't know what comes next. Something like that, you can, but you don't have to. And if you're ready, you can use this little, I call it play button. You can push the button and then you get a short dialogue. I'm sorry, it's all in German. I didn't mention that. It's a very German company. But right here you can see, you can choose something for a time limit, runtime, because sometimes you have much time, it doesn't matter, you want just the optimal solution and just go get some coffee in the meantime. And sometimes it has to be fast, because something went wrong, for example, and you want to react to a situation, and you can just put in here just a short amount of time or maybe a large amount of time. And another button you can use is KPI, that's international, I think. That's something we invented for purpose of comparing. For what happens is you push this KPI button and the optimizer will just calculate the KPIs, so mainly the objective values that it's measured at, and it won't change anything. But afterwards you can have a look at them and see what the planner has done. If this would have been produced the way he manually adjusted the program, you can compare it to what the machine would have done with the same program. It's very important because later on in the lessons learned you will see why we put this button into the tool. And now you just push the button to play, you want to optimize everything, and it just gets back into your dialogue. The optimizer runs in the background. Dependent on which plant you chose, in the drop-down menu at the start, you trigger a different optimization model in the background. So we write a model for each plant that adapts to the situation. And you can see the solution comes back and it's just displayed in the upper part. That's the direct solution from the optimizer. And people can now make adjustments if they want to. It's a support tool. They can use this solution, but they can change something. And maybe you notice that I just put in like 30 pieces and now it's 39. You cannot see, but I tell you. This is because there have been some values, some objectives that could not have been solved optimally. For example, the rules tell you these two pieces here, they cannot go one after the other, but it's not possible to avoid the situation. The Gurobi could show that it's not possible to avoid one of those red edges. So the user knows I have to interact here. I have to find maybe another piece that I put into to solve this situation, and he can see directly if it works because the rules will execute in the background, or he could put some more pieces into it and optimize again. But he just knows this way it cannot be produced. And if you're done with it and you're satisfied with your program, you can have a look at the KPIs. Of course, you can see I optimized this program 3 times. Maybe I made some minor changes to it. And over here, you can see the KPIs. Not so many because it's just a test system here. But this is something I showed you. It's just the objective values of all the optimization process. They are displayed here. And then finally, you're happy. You can use this button to send it to the production side. Just as I showed you in the first picture, it will go to production and they will do it the way you chose. Yeah, as I mentioned earlier, some lessons learned. Have a look at the time. I have to come to an end. The lessons learned, some technical challenges. For example, if you have live data and use it from your material tracking system, you have the problem that it's live. It may have changes while you are planning, and your plan may not work if the pieces in the background are changed. So we came up with a delta synchronization process that handles this and blocks the pieces for some other people so that I cannot take it away, for example. Also, just to shorten this up, we have stakeholder problems, as everyone. Optimization goals are hard to identify. If you ask a planner to make a program that is optimal, you get a different program when you ask a second one. And you get another 2 if you ask a third one. So it's hard to identify what is a good program actually, and to take all the people with you and to find acceptance of your optimization. So we try to incorporate them into the development, like sitting next to them, talking to them what they are doing while they plan a program and what should be done differently maybe in the future and things like that. But it's very hard to get them to accept the optimization as a tool that will not take their jobs away, but supports them. Yeah, but the achievements are that we have a central tool that is easy to be adapted to or to be rolled out for new plants, especially in the context of the next years, which is mainly facing the green transformation in the steel industry. Maybe you don't know, but steel industry causes 7% of the worldwide CO2 emissions. That's, I think it's more than airplanes, but you cannot build airplanes without steel. So, yeah. So we have this green transformation process to produce carbon neutral steel in the future. And therefore, it's very important to have tools that have a look at the whole supply chain, that have a look at the whole process, and that optimize for the future. Yes. And that's enough for me today. And maybe you have some questions, or we can talk to later at the event, whatever you want. Thank you.
I think we have time for one question.
Maybe.
Thanks, Annika. That was a nice presentation. And what you do in your company. I'm curious about the Delta Sync. Is it not better to have real-time changes already in your hand and then create the model out of those real-time changes as opposed to blocking changes?
Good question. It's a process. People are sitting on their computer, and if they don't work in seconds, they work in minutes, sometimes 30 minutes maybe, until they decide. And there's just too much time. And we have some time that the optimization uses itself. Let's talk about like 3 minutes or something. And things could happen in that meantime. They could just happen, and they are happening. It's a very fast progression that happens at the production side. So we have had many problems without this data synchronization process. But I'm not quite an expert on that.
I'm wondering, let's say, whether I'm wondering whether in that 3 minutes, for example, there's suddenly a storm coming in the country where your supplier is, and then
it's not the supplier; it's the production side itself, actually. But yes, we started without this synchronization process, and we had many problems. So it was something that came because it was necessary.
Great. So thanks for the great talk. I learned a lot about steel today. This is fantastic. I have one question. You were able to select the single plants. Are there any plans of you or your team to kind of select more than one plant which are kind of nearby, because we have this Ruhrgebiet in Germany and all of the areas below, which are not too far apart, which might profit from some common transportation routes or something like that? Are there any plans at your team?
You don't have to think of them spread around Germany. It's all at one production site, but we have programs where we take into account the following plant that comes, and they also consider the business rules that acquire to that following plant, so that the plan can not only work for this one, but the following plant as well. We do that, yes.